Presentation, I would like to give you a brief overview of the key aspects of GMO testing in cotton materials, in particular with reference to the recently introduced ISO IVA 32 protocol, which was published in 2019. Next slide, please. So first of all, I would like to introduce our lab to you, Eurofins GeneScan. We are located in Freiburg in the southwest of Germany, and we are the competence center for GMO testing within the Eurofins group. We have more than 25 years of experience in molecular biology testing, and our technical expertise is concentrated in two main departments: the testing service department for the analysis of routine samples, and the method development department, which is able to develop and validate different molecular biological techniques like or methods like DNA extraction methods or PCR methods, not only for our lab, not only for other labs of the Eurofins group, but also for external customers that might have a need for it. Next slide, please. So when we look at the global planting area of cotton, we can see that there are 5 main countries with more than 1 million hectares of GM cotton planting area. These are India, the US, China, Pakistan, and Brazil. As you can see, the great majority of this planting area is cultivated with GM cotton, while non-GM cotton or conventional cotton makes only a small proportion of the overall planting area in these countries. So looking at the global planting area, the percentage of GM cotton, the percentage of the area cultivated with GM cotton is around 76%. Next slide, please. There are several GMO cotton varieties, so-called GM cotton events, and this in each of these varieties, a particular exogenous gene has been introduced, which confers particular traits like to the plants, like herbicides tolerance or resistance to insects, or other peculiar traits. Next slide, please. So 2 of the main standards for organic cotton do not allow the use of GM cotton. These are the Global Organic Textile Standard and the Organic Content Standard. So based on this, or the requirement of these 2 standards is that organic cotton materials should be tested for the presence of GM cotton according to the newly developed ISO IVA 32 protocol. And the analysis has to be carried out in ISO 17025 accredited labs that has successfully passed the proficiency test for this protocol. The proficiency test was the first proficiency test for this protocol and took place last year. I would like to mention that our lab, Eurofins GeneScan, is of course ISO 17025 accredited, and is one of the labs that successfully passed the proficiency test last year. Next slide, please. So the ISO protocol describes three major points, three major steps. The first one is an effective way to isolate DNA from cotton materials. In the second step, it must be verified that the DNA isolated from cotton materials is suitable for PCR testing. So the DNA should, or the isolated DNA should contain sufficient cotton DNA for the PCR analysis. And the third step is the description of a screening method to detect all currently known GMO cotton varieties. Next slide, please. So how is the analysis performed at our lab? So first of all, when we receive a sample, we normally homogenize it to a fine powder. And a small portion of this powder is used for the DNA extraction. The DNA extraction, as well as the PCR analysis afterwards, are performed in duplicate. The DNA extraction protocol includes, of course, some controls to monitor the efficiency of the DNA extraction. Once the DNA is extracted from the initial sample material, its quality and quantity is evaluated to verify that they match the expectations for this material. So if the quality and the quantity of the DNA are match our expectations, then we can use this DNA for the PCR analysis. The PCR analysis is an enzymatic reaction that allows the detection of specific DNA sequences. Next slide, please. So the DNA sequences that are targeted in the PCR analysis in the ISO protocol excuse me, are 7. One of them is a cotton reference gene that is used as a positive control to check that sufficient and suitable cotton DNA could be extracted from the sample. The other 6 target sequences are screening elements for the detection of GMO varieties. So we can there can be different results combinations. First of all, it's important that the cotton reference gene is detected so that we get a positive result for it, meaning that the DNA is suitable for the analysis. If no GMO targets are detected, then we can conclude that no GM cotton is present in the sample. If one or more of the GMO target sequences is detected, then the conclusion is that the sample contains GM cotton. If instead the cotton reference gene is not detected, it gets a negative result, then no conclusion can be drawn about the GMO status of the sample, because no sufficient or no suitable cotton DNA could be extracted for an evaluation. Next, please. So during the validation of the ISO protocol, it was realized that only the production stages of cotton seed up to grayish yarn and grayish fabric are suitable for the analysis. because they, from them, on these stages, it is still possible to extract enough cotton DNA for the analysis, or suitable cotton DNA for the analysis. From processed yarn and processed fabric instead, no sufficient or no suitable cotton DNA could be extracted. Therefore, both the ISO protocol as well as the standards that I mentioned before for organic cotton state that GM cotton testing should not be carried out in chemically processed cotton because no suitable DNA can be extracted from these materials. So the ISO protocol stops here. It doesn't go further into an identification or quantification of the GM cotton varieties in the sample. This is an optional step that we can carry out at our lab, and that can provide additional information to you to look into the possible causes of the GMO contamination, GM cotton contamination, and also to have a better idea of the level of the contamination. But as I said, this is not part of the ISO protocol, and as well not part of the two standards for organic cotton that I mentioned before. So my part is over, and I can hand it now over to Javier.
Thank you, Francesco, for your explanation. It is very clear. And thank you, everyone, for joining us today on this webinar. In my case, I'm going to talk about the link that, of course, exists with the organic cotton and the chemical hazards, but also we will do a link with what Francesco has been explaining right now and the supply chain mapping or supply chain management. But before doing so, just allow me a couple of minutes to introduce Eurofins Soft Lines and Leather in the next slide. I think that some of you, or I hope that most of you know already our international business line. We are a global network of nowadays 10 laboratories which are located in China, Vietnam, India, Turkey, Italy, Germany, UK, Spain, and in the US, which are specialized in textiles, in garments, footwear, leather, also PPEs, and we are providing, of course, testing, inspection, and certification services across all these locations. Our two technical competence centers are located, one in Alicante, in Spain, in the southeast of Spain, and the second one in the UK, it's in Northampton. The one that is located in Spain is specialized in textiles, footwear, and PPEs. And also the one that we have in the UK is specialized from many years in leather testing and footwear as well. Of course, we offer a very vast and huge variety of services, and between them we can deliver full restricted chemical testing, which is required by the certification by the GOTS, by GOTS. In this case, we will be able to issue certifications as well soon. We expect to get accredited very soon, and then we can cover the full process. So thank you for allowing me just this brief presentation. In the next slide, I would like to go into details about the chemical hazards, but before entering into it, I would like to share, or that we learn all together, the definition of organic cotton, also because it's important to understand it. to what we are going to explain. So organic cotton can be understood in this case as one of these two definitions, which is cotton which is produced without using chemicals, man-made pesticides, or artificial ingredients. Or we can have a second definition, which is linked with what Francesco has been explaining, which is cotton, which is produced without proven toxic pesticides and or synthetic fertilizers using non-genetically modified seeds. Okay, this step of learning these definitions is necessary because not all the organic cotton in the market has been necessarily certified. Francesco already showed you two possible certification schemes for organic textiles or organic cotton, but it doesn't mean that necessarily that everything in the market that is claimed as organic is necessarily certified. In the next slide, we will see also that in a similar way, we have to learn why it's popular or what the consumers in this case may understand by a product that is being sold as organic, because as when you go to the market, to the shops, and you see that something is claimed as organic, not only in this case talking about textiles, could be from food, for example coffee, or to any other product. These claims maybe make you think that the product is more ecological or environmental friendly, that is greener or more sustainable, that is safer from hazardous chemicals or healthy for consumers, or that can be fairly produced, or that promote the biodiversity. These are just examples of the claims that maybe consumers can think when we think about, in this case, organic cotton. But again, all these claims together with the one of organic have to be demonstrated. If we go to the next slide, and coming back to the certifications that Francesco has introduced before, we can see that the certification criteria cover many aspects on the value chain, not only the assessment of presence or absence of GMO or genetically modified cotton. In this case, we can see that the different aspects that are assessed goes from environmental topics such as the water consumption or pollution, the emissions, to social considerations, the chain of custody and the traceability, which is very important here to assess the traceability of the whole supply chain, and of course the presence of hazardous chemicals. In this case, it has to be considered that as well exists legislation which is applicable to textile products. For example, if you have attended previous webinars that we have delivered, we have explained about the different legislation that exists, and later I will be talking about just few examples, 5 or 6 examples of chemicals which are globally restricted in many countries and many regions, and that are also included in these two certification schemes. But these chemicals can be found in different stages, and it's important that we assess as well and that we understand the supply chain of our product. So in the next slide, we are providing this is an example that maybe is not 100% accurate, just disclaiming this because the processing step, you are familiar with the production of a fabric, could be placed in different stages. But just if we see this example of value chain for cotton production, from growing cotton to garments production, we can see in all processes that different chemicals can be used, being in this case, of course, the processing steps where more chemicals are being introduced in the value chain. As I mentioned, the processing can be allocated in different stages. So why it's important to know about the process? So as mentioned, depending on the step, and in here I'm talking now more about providing you solutions of risk-based approach for testing. In this case, as I'm mentioning, depending on the step where we are, the targeted chemicals could be different. So it is not the same that we have grades or raw material, in this case fiber, which has not been treated by or processed by any manner, is basically raw cotton, than if we are, of course, after a dyeing or printing process. The number of chemicals are different, and the risk of finding some of them are very different. So in this case, we are providing also some examples of chemicals which might be found in the different stages here. In the next slide, for example, if we focus on the cotton growing and lean, we can find, for example, pesticides. Pesticides is one of the substances which are controlled, for example, in the two certification schemes that we have mentioned. As most of you may guess, they are used basically for the management of pests or vegetation, but also can be used, in this case not related to organic cotton, to animal skins or animal fibers in order to preserve them and to avoid any growth of any pests in these animal skins or fibers. So pesticides, I'm mentioning them here, of course, because normally if pesticides are used in the cotton production, they are used in the early stages, so when the cotton is growing. But of course, pesticides also could be detected in further steps of the production chain. So there could be remaining traces of these substances that can be detected, for example, after weaving or even after dyeing. In the next slide, you can see that we are providing here another example of chemicals, which is the PAH. This is the polycyclic aromatic hydrocarbon. In this case, we are placing this chemical in this step, in the spinning and the weaving and knitting. But maybe you are thinking, okay, these two processes are basically mechanical. So why these chemicals, no chemicals are normally added? If you see, we are highlighting one of the chemicals in red, which is the lubricants. PAHs also can be found in other chemicals, or can be used in other chemicals, like for example, pigments and dyes, of carbon black, printing pastes, dye dispersing agents, plastic or rubber components, and coatings and lacquers. But also can be used in lubricants, and these lubricants, of course, can be used or are used in this case in the machinery that is processing the cotton or any other kind of fiber. So in this case, we may consider that these PAHs could be resulting of a contamination, and also can be also a byproduct of a reaction, or for example, in the finishing processes where some fire can be used in the rain. These PAHs also can be formed naturally. So it's very important also that we consider these stages. Then in the next slide, we are already focusing in the processing part, where more chemicals are used, and we are talking here about one of the most known chemicals. In this case, we talk about the formaldehyde. If you are familiar with it, is a chemical which is classified as carcinogenic, is prohibited or restricted in many countries worldwide, and of course is as well included in the GOTS and the OCS standard certification schemes. In this case, formaldehyde can be used, mainly we are talking about it in the processing and in the finishing, but also can be used for another chemicals like resins, prints, adhesives and glue that can be used not only in textiles, but in other consumer products as well. The next chemical that we are talking is the azo-dyes, if I'm not wrong. Next slide, please. Yeah. Also are very well known, and these are restricted in many locations globally. For example, in Europe, in the US, in China, in Saudi Arabia, Korea, Canada, Taiwan, Hong Kong, and many locations are prohibiting or restricting the use of azo-dyes and its salts. As the own name indicates, they are a consequence, or they are present in dyes and prints that are used mainly for textiles, leather, and for synthetic leather. They are also, of course, restricted in the GOTS and the OCS standards in this case as well. Next, I think that this is the last chemical we are talking about, and it is the carcinogenic dyes. This would be, and the allergenic one. This would be similar to the previous one. These carcinogenic or allergenic dyes are used mainly to dye textiles or for polymer solvent dyes, and these are classified as carcinogenic and allergenic and are as well prohibited in many locations. So if we go to the next slide and just to arrive to kind of conclusion, as I was mentioning at the beginning, not all organic cotton should be claimed as organic, because if we consider the certification schemes that we have been shown. So as you saw, there are many requirements that organic cotton has to comply with, and one of them is complying with the chemical restrictions that may come from, in this case, from a certification scheme like the GOTS, or for example, from the legislation that is applicable where the product is being sold. So in order to make sure that something that is claiming as being organic is necessary as well to control the supply chain. And in this sense, I want to mean here that in order to make sure testing, of course, is the ultimate option that you have to make sure that your product does not contain any hazardous substance or any restricted substance. But you have the option, of course, of conducting additional activities in your along your supply chain that can include, for example, auditing your supply chain in order to understand which chemicals are being introduced during the production of your chemical. And this will help also to reduce the amount of testing that has to be performed at the end of the chain. Because if, for example, I don't know, in this case, if you are producers of raw materials or intermediate or semi-elaborated materials, or if you are retailers just selling the garments. If you are located, obviously, at the last step before placing the goods and selling them to your consumers, if a chemical is found, then it's quite difficult to solve this problem if we are at the end of the chain. But if you control the traceability of your supply chain, that this is something that, for example, the GOT certification requires, is control traceability along the supply chain. will be easier to implement any corrective or preventive action plan. So to finalize here, it's necessary to ensure that the production and the textile value chain does not include any restricted or prohibited chemical, but also you need to remember that there are other aspects that makes a cotton to be organic, okay, with the other claims that we discussed. And then just to finalize a brief summary of what we have been talking before you can ask us and we can answer your questions. As Francesco has explained to us, they have the expertise of their laboratory in Germany to provide the GMO testing with the competence center located in Germany. In addition, we have a business line which is 100% focused in textiles and garment industry, in this case, providing testing, certification, and audits, and inspections, of course, as well. Besides the comprehensive solutions that we developed from the organic cotton marketing inception, we also provide, or we are flexible in providing services and we adapt to our customers. Important to mention here that for these certification schemes or for this organic certification, and especially the GMO testing, is everything conducted by laboratories in Europe without any subcontraction. So everything is made in-house in Eurofins. And as Francesco has mentioned, Eurofins is one of the few labs. I don't know if it was the first or one of the first laboratories in getting the accreditation and passing the proficiency testing to be accredited with the ISO IWA 32 standard. And that's it, basically. Let's see if we have some questions to answer.
Okay, thank you, Javier and Francesco. Hopefully everyone's found that insightful, and we'll let Javier and Francesco have a break. And it looks like you're quite shy with the questions, so if you do have any, please send them across. Javier mentioned our organic cotton testing services there, so if you have a look at the handout on your right there, you should be able to see more information on those if you're interested. And if you would like us to follow up with you, you can always raise your interest in the chat box now. So let's see. Okay, no, it doesn't look like you have any questions, so good job, Javier and Francesco. You must have been very thorough in your coverage.
Yeah, okay. If now maybe the people needs to digest a bit about the information that Francesco and I have been sharing, but then if you go to the next slide, I think that they can get our contact details. So if you have a question later today or later this week, you can contact us and we will be pleased to help you.
Yeah, and just a reminder that a recording on the slides for this webinar will be shared in the next day or two. So thanks very much, everyone, for taking the time to view this webinar, and thank you, Javier and Francesco, for putting it together. And if you do have any questions on this session, please feel free to reach out. So we hope to see you again for our upcoming webinars. And just before you go, when the session ends, you'll be asked to fill in a quick survey to give us feedback. So please spend 2 to 3 minutes on that. It'll help us with our future webinars. So thank you, everyone, for joining us, and take care. Goodbye.